All right, so just make sure that you watch the Fission-Fusion video and answer those questions first before doing this one. That video obviously is about how fission and fusion works. These are the two types of nuclear energy we use. Fusion is when we smash atoms together and we fuse those nuclei together to form a larger atom. Usually it's with hydrogen or helium. We can't really control that process right now. We're not getting, it takes too much energy to bring them together, and we don't get enough energy out right now. We're still working on that. It's always an area of research. Ideally, that would be the best because there would be no radiation, and it'd be nearly limitless energy, right? We have a lot of hydrogen that we could use, and it's so it'd be really effective if we could use fusion, but that's still research. So instead, we use fission, which we take really big molecules, big nuclei, and we split them apart, like uranium or plutonium. But as they do that, they send off higher energy particles, and that's that radiation, and that's gamma rays and all that stuff that can really hurt humans. We're really good at containing it. It's fairly safe, but it's very expensive to keep it so safe. And so whether we want to use them or not is kind of a question. But first, we kind of want to understand how we use fission to create nuclear energy. We do it here in California. We do it all over the country. A lot of countries, different countries use it to get energy. We also use it for bad purposes, obviously, like bombs and things. But today we want to talk about how we use it for good things. So, nuclear reactor simulator. So if you can use this link and go to it, that'd be great. It's really good if you get to play around with it yourself. The simulation itself doesn't work really great. It's sometimes it works, sometimes it doesn't. So if you can get it, you should go ahead and try. But if you skip all this detail stuff, if you are going to do it, don't let them ask for that stuff. The first thing we're going to do, this is a special type of nuclear reactor called a pressurized water reactor. We're going to take a tour of what happens here. So I'm gonna kind of go through this, but I really want you to kind of pause it and look and read everything, because I'm gonna go through it kind of quickly. So pause it and read everything so that you can answer the questions. So makes electricity using the same principles as coal, oil, and gas, and we already talked about that. How they burn things, create heat. That heat boils water. That water boils and turns a turbine, which turns a generator and creates electricity. So we're going to do the same thing, except we're using nuclear fission now to do this, to heat the water. It creates a lot of heat and a lot of energy. So first thing, here's a description of nuclear fission. Okay, what is nuclear fission? That video talked about it, but if you want to read a little bit more, you can pause the video and read this. It is clean energy besides the radiation, but radiation can be pretty well contained in the buildings. So it's actually a very clean energy, no CO2. Okay, next we have the reactor core. This is where all the good stuff happens, all the heat and things that occur. Thousands of uranium fuel pellets and metal tubes. We call the fuel rods, right? We don't need very much of it, as it talks about here. Pause this and read it. Here are the control rods. So control rods are very important to keep them safe. They allow, they kind of absorb the extra uranium neutrons that are coming off, so that way it doesn't heat up too much. So it kind of slows down the reaction. We can raise and lower them in order to contain the reaction a little bit more. So pause and read this. Okay, the coolant, obviously very important. That's why we don't want meltdowns to occur, and so we really need coolant and the coolant pump to work really well. A lot of times the coolant pumps break and due to like the tsunami or something like that, and that's why nuclear disasters happen. So coolant is very important. Read this. Okay, control rods. The pressure vessel, sorry, this is what we contain everything in. Very important, obviously. Okay, coolant pumps. I talked about the fact that we really need to run those and keep them running. They're very efficient. They're very powerful. It talks about right on here, so you can pause that and read that. Okay, the pressurizer. Go ahead and read that. Okay, steam generators are obviously very important because that's where we're actually getting the power from. The steam turns the turbine. They're very big, as it says here. And the steam is in a separate system as the heat. So the heat heats up the water, but they're separated from each other. That way you don't have any radiation in the heat, the steam that comes out of the power plants. Okay, here's the turbines. These are just like windmills. You pump that steam through there and it causes them to spin. So they're like fans, little fans that spin due to the steam. And they're really effective. They do it very, very high speed. And then those turbines turn the generator, and that's where we just have a magnet or a loop of wire, and we spin them, and that creates electricity. We talked about that right before spring break. It's before learning about nuclear energy, we learned about how, just like in class, we had those little motors spinning. You can do the opposite and just spin the motor itself, and that will charge the electricity. All right, condenser, basically because we don't want to waste water, we condense that water down again, so that way we can reuse it and turn it back into steam later. All right, so I'm just gonna, you should try to do this yourself if possible. It's kind of fun to try to make sure everything is working well, but I'll just kind of play it for a little bit and you can see what's happening as I go through this. So I'm gonna turn it on. So we want everything in the green, obviously. So we have some out demand and we have no output. So we got to raise the control rods so that way there's some energy going through, and then create some steam. So as I increase the steam, obviously everything is spinning now. Here we're creating electricity, but I need to create enough electricity to meet the demand of the country, which obviously peaks usually actually in the afternoon, especially on the weekends. And then usually at night it'll go down again. So here's my output, here's my demand. So I'm raising the control rods, so that way more fission is occurring, but it creates a lot of heat. So we need to make sure that the coolant pumps are running and that we're creating enough steam for the power generation. Now what happens if I were to keep the steam high, but then like drop the reaction? You see I am tripped, the reactor tripped. So it shut down by itself as a safety measure. So because I lifted those control rods out, it's saying, oh, it's gonna get too hot, and so it shuts down itself. So that's how we make things really, really safe. Okay, so go ahead and play with this if you want to on your own, if you can. Otherwise, go ahead and go in here and answer all the questions based upon this video. There's a little challenge question here that why would I want to have batteries next to the power plant to help during peak times? We actually use these batteries nowadays for with renewable energy. It really helps because when it's not sunny out, where do we get the energy? Well, we need batteries to store the energy during the day. That way we can use it during night and stuff like that. All right. The last thing is there's one more little essay you need to write. A really short essay, just kind of answering the question is why do we want or why do we not want nuclear power? Make sure you email me with any questions or stop by during office hours.